Okay, so listen up. So quadratic sequences, we're going to look at quadratic sequences now. The last couple of lessons we looked at arithmetic sequences. What's arithmetic sequence again? It's a common first difference. In other words, you add or subtract the same common difference to get to each other term. So like 5, say for example the starting term is 5 and the difference is 3, so it's 5, 8, and then 11 and 14 and so onwards and the rest. Geometric sequence. Leah, what's a geometric sequence?
It's like
Multiplication or division from one term to get to the next term. So the ratio, for example, is now 3, and the first term is 2. Then it will be 2 times by 3 is 6, times by 3 is 18, and so it goes on. Okay, so that's it. We looked at examples of those yesterday. So now what we're going to do is we're going to look at quadratic sequence. Quadratic, we see it is a what type of graph will a quadratic sequence make?
Quadratic one.
Yeah, and a parabola. A parabola is a quadratic equation, right? So let's go through it. So let's start with how would it look like? Okay, and what did we say? What is the definition of a quadratic sequence? What makes a quadratic sequence a quadratic sequence again? There's a common second difference. Right? A common second difference. What does that mean? You take the differences of the differences must be the same. Okay, must be common. Okay, so let's start with a couple of examples. So I want you all to form a quadratic sequence. Okay, so I'll start the show and say, okay, so let's start with the first one is 2, and then what do I do with that? So say for example 2, what can the next term be? So say for example it's 6, and then so what's the difference between 2 and 6? The difference is 4, all right? So, and then, so this be looking at the second differences must be it must be constant. So say the common second differences must all be 2. Okay? What is 4 plus by 2 is 6. Do you follow? And what will 6 plus by 6 then be 12? Do you follow? The common second differences must be constant, so that must be a 2 again. So what do I need to add to 12? What's going to happen then? So it's 4 and then 6. 6 plus by 2 is going to equal to 8. And what is, bless you, and then what is 12 plus by 8? That is going to be 20. Does that make sense? So that's a quadratic sequence. It's got a common second difference. What do we notice about a sequence like this? So before we do that, let's just do another one. Josh, give me a starting term.
10.
10. And thanks, Josh. And then let's go. Give me the first difference, Greg. What can it be? Any 3? Awesome. So then the second term would be 13, right? You're right. Tim, give me the constant. What should the constant second difference be?
1.
1. Okay, that's all right. 1.
1.5.
No, let's just do
27
1.
and a half.
Thanks, Tim. So, okay, so therefore 3 plus by 1 will be 4. What is 13 plus by 4 going to be? That's going to be 17. What should the next one then be?
1.
Yeah, so that should be 3, 4, 5 for the common second difference to be 1. So 17 plus by 5 then is equal to 22, and so onwards. What do we notice about these two sequences? Look at the first differences. What do you notice, James, about the first differences? In the first one is 4, 6, 8, and then the second one is 3, 4, 5. What type of sequence does that make? Yeah, what type of sequence? So we get arithmetic sequences, geometric sequences, and we get quadratic sequences. 4, 6, 8 is a what type of sequence? It's got a common first difference. Yeah, absolutely. So it says it's an arithmetic sequence. Do you follow? You plus 2 to every single term. What about 3, 4, 5? What type of sequence does that make? It's also arithmetic sequence because in this case you're going to add 1 to every single term and you get to the next term. Does that make sense? And what about the second differences? The second differences will always be the same, like 2 to 1, 1, and so onwards. Does that make sense? So that's one way to do it. Okay, can you all quickly make a quadratic sequence? Make up your own quadratic sequence and then... Okay, here we go. James, what was your quadratic one? Hey. Yeah, just what's your sequence?
6, 9, 14, 20.
Oh, 6, 9, 14, 21. Let's check it out. So that this first difference is 5. And that will be... No, I'm sorry. I can't add at all. So that difference is 3. The difference is 5. The difference is 7. So the common... So 2, 2. Well done.
Not the exact numbers, but...
Okay, Greg, yours one? Your one?
3, 5, 11,
3, 5, 11, 21. So that is 2, that is 6, that is going to be 10, so that is 4, and that is equal to 4, common first difference. Awesome. Sebastian, yours? Oh goodness, if you missed that, you just sneezed 3 times. Help us. So,
Sneezing is not a symptom.
I know. Sebastian, you're going to...
Mine was
4, 8, 14, 22. So that's 4, that is equal to 6, that is equal to 8. Common first difference. You like a common first difference of 2, no? So, Tim, your one?
5, 9, 19.
And we can always count on Tim to be a bit odd. So what's
35.
35. So then that is going to be 4, and that's going to be 10, and that's going to be 14.
16.
16 rather. And therefore that is equal to 6, and that is equal to 6, and therefore common first differences are 6. You guys go? Good. Now listen, now very important. So this is a bit unusual, this type of sequence, right? But now we need to think of a way to find the general term. Okay.
Do a minus one,
You could do negative ones as well. Is it possible for a quadratic sequence for 2 of the terms to have the same value? In a quadratic sequence for 2 of the terms to have the same value?
Well, if the difference is just 0.
You tell me what you
No, but if the difference is 0, then the second difference, if that's just 0, 0, that's not... That's as inspiring as Donald Trump's hair. So, hey? It would be possible. Why?
The first difference can change signs and then you can go back where it was.
Okay, so for bonus marks, if you can think of a quadratic sequences where 2 of the terms got the same value, I'll get you a bottle of hand sanitizer. So,
If you get it.
yeah, now they're all working. Okay, here we go. Now listen, this is important. To work out the general term, so the general term of a quadratic sequence, the format of the general term of a quadratic sequence is an squared plus by bn plus by c. Okay? So a is the coefficient of n squared, b is the coefficient of n, and then c is the constant term. Now this is important. Hey guys, please look here. So here we go.
Well, it's pretty quadratic to me.
Ah!
Wonder why.
Parabolic there. So here we go. So what we've got is, if we've got term 1, and we've got term 2, and we've got an squared plus bn plus by c. And then we've got term 4. We've got difference 1, first difference 1. We've got difference 2. We've got difference 3. And then we've got common difference. And then we've got the common difference. Does that make sense, what I'm doing? I'll explain to you now why we do this. Okay, so what we're going to say is 2a is equal to the common difference, common second difference. 2a is equal to the common second difference. I can explain it now. Then 3a plus by b is equal to the first term of the first difference. And then lastly, a plus by b plus by c is equal to the first term. So that just looks...
I did bring my math book. I just remembered.
Oh, well done, Tim. So, a plus by b plus by c is the first term, 3a plus by b is equal to the first term of the first difference, and 2a is equal to the common second difference. Okay, what the hell does this mean? Good question. So if we have a number pattern, so say for example 3, say plus by 4 is equal to 7, plus by, so let's make that 4, and then that is equal to 12, so that is equal to 15, and then the next part, 8 plus by 12 is equal to 20, so that's equal to 35, and so onwards. Is that a quadratic number pattern? 3, 7, 15, 35? No, it's not. Okay, so we've got 3, 7, 15, 27. The first, so 4, 8, 12 is equal to your first differences, and then the common second difference is 4. Okay, so that makes a quadratic sequence. So what we're in other words going to do is we're going to say 2a is equal to 4. We're going to say 3a plus by b is equal to 4 as well, in that case. Okay, and then we're going to say a plus by b plus by c is equal to 3. Does that make sense? So in other words, you just need to remember, just for now, I'll show you the proof now. 2a is equal to the common second difference, 3a plus by b is the common first term of the first difference, and a plus by b plus by c is the absolute first term of the sequence. So let's play with it. So the first one, 2a is equal to 4. What is a then equal to? 2. You okay? You start from the bottom and you move upwards. Yeah? Next part, the first term of the first difference, 3a plus by b is equal to 4. Do you guys agree with that? But what is a now equal to? A is equal to 2. So therefore, we can substitute 2 into a. So therefore, we've got 3 times by 2 plus by b is equal to 4. What is that then equal to? 6 plus by b is equal to 4. What does that mean? B is equal to minus 2. Yeah? And then lastly, we've got a plus by b plus by c is equal to 3. Okay? We have a now. What is a equal to? 2. Awesome. And then we've got b now. B is equal to minus 2. We just worked it out there. Right? Minus 2. And then we've got plus by c is equal to 3. So what is that equal to? C is equal to? 3. Yay! We've got a, we've got b, we've got c. What is the format of a quadratic sequence again? Remember what we said? It is equal to an squared plus by b n plus by c. So write it down. So therefore, Tn is equal to n squared, an squared plus by bn plus by c. What is a equal to? We said is 2. So it's 2n squared. What is bn then? Minus 2n. And what is c? Plus by 3. All right. I don't think that's too bad, eh? Not at all. All right. What is the quadratic? What is the general term? What can we do with it again? What's its purpose again? You can find the value of any term or which term is equal to a certain value. So say, for example, I ask you, what would the next term be? How many terms we had? 4, right? What would be the next term? So notice, what would the value be of term 5? So what's the value of term 5? In other words, what you're going to do is you can say Tn is equal to 2n squared minus 2n plus by 3. So term 5 is equal to 2 times by 5 squared minus 2 times by 5 plus by 3. And what is that equal to? Yeah, 25 times by 2 is 50 minus 10 plus by 3 is equal to 43. In other words, what is that? And let's see if it's correct. How do we know if it's correct? What would the next part here be? We need to add what? We need to add 4, 8, 12. For that should be 4 as well, so that should be 16. 26 plus by 16 is equal to, what is that equal to? 33, 43. Yay, 43. That is the next term. Okay, so that's quite cool. Right. Say, for example, I gave you the value of a term. No? So, say, for example, I tell you. So, say, for example, I ask you which term is equal to 183. What will I do now? So again, what's the general term? Tn is equal to in this case 2n squared minus 2n plus by 3. Now we have the value of the term. What is the value of the term? It's 183. So you know what the answer is, right? So it's 183 is equal to 2n squared minus 2n plus by 3. What do I do now? Minus 183 on both sides. So 2n squared minus 2n. And then minus 183 on both sides. So that's equal to minus 180. You guys cool with that? And you're going to divide every single term by 2 now. So n squared minus n minus 90. Do you guys know your factors of 90? Added together is equal to minus 1.
10 minus 10.
Yeah, so n minus 10 and n plus by 9. So therefore, n minus 10 is equal to 0, n is equal to 10, or n plus by 9 is equal to 0, n is equal to minus 9. Okay, which of those two would it be? Of course it will be
10.
term 10. Can it be term minus 9? No, that's a bit weird. I mean, how can you, then you need to go to term 0 and then, I mean, that just doesn't make any sense. Okay, so you're going to take the positive integer, of course. Okay.
And then both integers are positive?
You won't. There's no quadratic sequence where there's going to be. Oh, except of course if two terms got the same value. Sorry, correction there. So but those are isolated cases. So, okay, probably shouldn't use that word in this context. Okay. Okay, so listen. So let's look at two of them. Let's try to find the general terms of two of those of the sequences that you thought of. Can you guys do that quickly? Can you find the general terms of each of those? See if you can do it.
And then,
So let's start it. So it's 2a is equal to 2,
yeah.
right? So 2a is equal to 2, a is equal to 1. And then we've got 3a plus by b is equal to 3. So 3a plus by b is equal to 3. So it's 3 times by 1 plus by b is equal to 3. So b is equal to 0, yeah? I agree with that. And then we've got a plus by b plus by c is equal to 6.
What did I equal to? I equal to 3 as well.
Yeah.
I got 9, I got
So
9.
it's 1 plus by 0 plus by c is equal to 6 and c is equal to 5. Yeah. So then remember it's Tn is equal to an squared plus by bn plus by c. So then it is n squared plus by 0n, you don't need to put that, plus by 5. What happens there? Josh, you speak to me then. So 2a is equal to what?
2.
4 you say? So therefore a is equal to 2. Yeah, that's what you mean, I think.
Sorry.
No, that's right. So then 3a plus by b is equal to 2. So that means 3 times by, and of course 2 goes into a. 2 plus by b is equal to 2. So therefore 6 plus by b is equal to 2. So b is equal to minus 4. And what is the last part? A plus by b is equal to, c is equal to 3. And we know what a is. 2, we know what b is, it's minus 4. What is that equal to? 5.
5.
So therefore, what's the general equation? No, don't leave it like that. I freak out when people just...
Tn.
So Tn is equal to an square, so it's 2n square minus 4n plus by 5. So in other words, if I want to work out the value of term 10, what is the value of term 10 going to be?
T.
2 times by 10 square minus 4 times by 10 plus by 5. T10 is equal to 200 minus 40 plus by 5. And that is equal to 165. All right.